Okay, we're going to do some polynomial equations, and this is a good intermediate step for us to understand how to use our reduced equations and then go back and review quadratic equations. So, solving polynomial equations given a root. So this is my polynomial equations. It's x cubed minus 11x plus 20 equals 0. So I want to solve it. That means I want to find all the roots. Since the degree of this polynomial is 3, I know I'm going to have 3 roots. This tells me how many roots I'm going to have. The highest degree of any term, which is the degree of the polynomial. So it's degree 3, so I've got 3 roots. I'm given 1, so I've got to find the other 2. I know that if x minus 4 is a root, x plus 4 is a factor of, and I can call this p of x, polynomial of x, or f of x if you want. So it's going to be a factor of this. So we can do long division, and we know our remainder will be 0. And we'll have our 2 factors, this and whatever the quotient is. Or I can do synthetic division. So I'll choose to do synthetic division. That's a little bit easier. So I'll say minus 4. Draw my corner. And divide by that. And then I'm going to use 1 for x cubed. And then I have a 0 times x squared. So I'm going to put a 0 here for the x squared as a placeholder. Minus 11 plus 20. And you draw your horizontal line and bring down your 1. And then you're all set up for your synthetic division. Negative 4 times 1 is negative 4. Add, I get negative 4. Negative 4 times negative 4 is positive 16. Add and you get positive 5. And negative 4 times positive 5 is negative 20. And you add and you get 0, which is what you would expect if that's a factor. So now we've got our reduced equation here. X squared, remember it's 1 degree less. If this is 3, this is going to be 2. X squared minus 4x plus 5. And that's your reduced equation. That's the whole point. Now once we have the reduced equation, it's a quadratic, and we know how to solve a quadratic equation. We've got 3 ways. We can either factor, complete the square, or use the quadratic formula. Can I factor this? Do I know 2 numbers that multiply to give 5 and add it to be 4? No, I don't think so. I'd have to have the same sign. 1 and 5, add it to be 6, so it doesn't work. So, I don't think I can factor this, because this tells me the signs are going to be the same. The only way I can get 5 is 1 and 5, and that's not going to work. Okay, negative 1 and negative 5 is negative 6. So I have to solve it a different way. So we either use the quadratic formula or complete the square. Since this is 1 and this is even, completing the square will be my best option. It'll be the easiest way. So I'll rewrite this: x squared minus 4x equals, and I'll subtract 5 from both sides to move the 5 over on the other side. So we just subtract 5 from both sides. And I have negative 5 on the left. And then I'll complete the square on the left. So what's square root of x squared is x. What's the square root of 4? 2. What's 2 squared? 4. So I'm going to add 4 to both sides. Plus 4. Plus 4. And now this factors the b, the squared, and this is going to be my sign. And I'm going to have an x and a 2. X minus 2 squared. And that's going to equal negative 1. Then I use my square root rule, so I know if something squared equals a number, then that something equals plus or minus the square root of that number. So I know that x minus 2 will equal plus or minus the square root of negative 1. But the square root of negative 1 is actually the same thing as, we call that I, because it's an imaginary number, so plus or minus I. And then I'm going to add 2 to both sides, so I can rewrite this: x minus 2 equals plus or minus I. And then I'm doing to add 2 to both sides to solve for x. Sorry, my cat was scratching the chair I'm sitting on. And what we end up with is x equals 2 plus or minus I, and those are your other two roots. So we were given a root of -4, so when we write our solution set, that will be a set of my three solutions. My first one was -4. My second one is 2 plus I, and my third one is 2 minus I. And those are your three solutions, okay? And it's a set. My first bracket was kind of crummy, so I can redo that. I can do a better job on that. And remember, a set is just a collection of objects. In this case, the objects are the roots for this equation. There you go. Okay, so there's your solution set, -4, which was given to us, and then we found these by finding the reduced equation, and then completing the square process. Okay.